Welcome to the short LATEX training. Today's training we are going to discuss about the set theoretic notations in LATEX, as well as we all are also going to discuss about the sequence and series in LATEX. The training is provided on Overleaf. So let's move on to the Overleaf system. To discuss about the set theoretic notation and sequence and series. So now set theoretic notation means we will discuss about that the sets and its subsets, and how the elements of sets is content over there. So start with begin line and end align. So first we will discuss about the subset. So subset is A subset B. So this is presented as like this, A subset B. Now if we have something subset equal, or if subset is equal with the superset, then we'll write subset EQ. And if it is not equal, then we'll say that subset NEQ. So it is will be presented like that. So this is possibly that A is equal B, but in this case it is clear that A is not equal B. A is proper subset of B. Now the equivalent set. So two equivalent set is represented by this code EQIV. So EQIV presented here is the equivalent of the set P, and the outcome is look like this. Okay, then we will take the union of two sets. So it is written as cup A, cup B. So A union B. And then you will have here intersection. Intersection is denoted as cap, CAP, backslash cap, and this will gives you A intersection P. Then we'll have subordinate set. So A PREC B. So it will come like this notation, and it's denoted as subordination. Then if you have the index, means infinite number or a big set of numbers of sets, so we can write it here union in terms of the indexing. So here I is equal 1 to n AI. So this will be written like this: big cup or big cap. So if intersection is big cap and union is big cup. Now element of a set, an element x in A and x is not in A. So x in A means x belongs to A, x not in A means x does not belongs to A. Now writing of a set is given as, let's x in A. So here is the curly bracket, and then x belongs to A such that fx equal 0, or let's say x belongs to A if x is integer. So in this case you see that is integer is a text, so we write it here like this. Okay, so this is all about the basic requirement of the set theory, and if any extra thing is needed you can define yourself, or you can get the idea from any other place, but these are the basic requirement of set theory. So next we will move to the sequence and series. Okay, so sequence and series is we are writing in the between begin align star and end align star. So first we will check that about the sequence. So sequence is written as in this form: I is equal 1 to n. If it is infinite sequence, then it can be written as up to infinity. And multi-index or two-index sequence can be written as like this: Aij, I and j is going to 1 to infinity. Then the series is written as like this: sum I is equal 1 to infinity a I. Means sum of the term of the sequence is gives us a series, and product form of the entries of series is given as PROD I equal 1 to infinity a I. So that's all about the sequence and series. So in the next lecture, we will see about the ascents in math mode and within text. How we can write the ascents in within math mode, as well as we'll see how we can write without math mode, that is in the text form. So that will be discussed in the next lecture.